All right, so this is an extension of what we did yesterday. This is 4.2, the first example right here, 4.6. We've got 16 to 3 equals d to 6. Remember, we're talking about ratios, not fractions. So it's 16 to 3 and d to 6. So we do our cross product property, and then we simply divide by 3, division property of equality, and we get our answer. Now notice this 3 and 6. What's 6 divided by 3? Well, it's 2. 2 times 16 gives me 32. You can do it either way. I'm just trying to show you some fraction tricks. Instead of doing 16 times 6 and then dividing by 3, let's just divide 6 by 3 to get 2. Makes it faster. All right, so now you must write full complete sentences. In a full sentence, at least one method of solving a proportion. What's one method of solving a proportion? And I want it in sentences. Note they're already in sentences. Shouldn't be that hard. Take your time. Example 4.7. Now this is what happens when we have groups on the bottom. Notice they're no longer just single digits. We've got to have a group. We still use our cross product property to set up these distribution scenarios. So we have to distribute the 4 and the 10. The distributive property. We know it's a distributive property. That's the reason why we're doing it. Now we're going to combine like terms. We're going to subtraction property of equality to get the 20 over. And then we're going to use the addition property, add the 8 over. And then we're going to use division property to divide by 8. Now, no mixed numbers, no decimals, just reduce the fraction down. 68 eighths becomes 34 fourths, becomes 17 halves. Can't go any further than this, so we leave it as 17 halves. I'm going to be very clear on this. No mixed numbers, no fractions. Division property of equality and the reduce. Okay, right here. Here we're doing it now. Instead of doing it with numbers, we're going to do it with segment lengths. So if we're given that AB equals BD and AC equals CE, we're going to find out what BD is. Okay, so we're still going to end up with the given. Now we've got some information. We're going to substitute in the information. On your diagram in your notes, it should look with the information. AB is 20, 16, and 9. And we're going to substitute that in. Now it looks here like we're going to switch it. Instead of having 20 over BD, we switch the means, and we get 20 over 16 equals BD over 9. Now I can reduce down the interchange means property. I can take 20 over 16 right here, and I can reduce that down to make the number smaller, which is nice. So we reduce the fraction. And now we do our cross product property. And now we divide by 4, and we get 45 over 4. Notice how we can't reduce that any further. It's already simplified. Now there's a lot of ways. We didn't have to do the interchange means property. We could have done 20 times 9 and then divided it by 16, but that seems like a lot of work. It's nice when you can notice there's even values, because then you know you can reduce it by at least 2. Probably more like 4 or something else. Okay. So that's just one way to look at it. There's lots of ways to do these problems. That's just one of them. All right, so now I've got this kind of a situation. Here's the picture drawn for us, and here's the picture drawn for us. And they're telling us that 4 compares to 8, and 5 compares to 4. So 4/8 is equal to 5 over x. All right, so we do the cross product. Well, that's just proportionalized. That's just given to you. We have to write it as a proportional statement. All right, and then we look here and we say the cross product property. We're good with this. If you'll notice here, the reason the 4 and the 8 compare is they correspond to the same location. They're the shorter segment right next to the 90-degree angle. Shorter segment next to the 90-degree angle. And the 5 and the x correspond because they're next to the 4 and next to the 8. That's how we can set up this proportional statement. All right, so now we just did the cross product. And then we divide by 4 to both sides, and we find out that x equals 10 by simplifying the fraction. All right, so now we take that information and we look at the angles. Here we're saying that 116 equals y minus 23. If I look on the paper, I see y minus 23 and 116. Notice how y minus 23 is between x and 8, and 116 is between 4 and 5. Those angles correspond to the same location. So we can set them not necessarily, yes, equal to each other. Because the shapes are proportional, we can say the angles are equal. So corresponding angles are congruent. Now that's not like in the parallel with a transversal, that's more like in a similar shape scenario. So now that we've got that, we add 23 to both sides, and we get 139. I want to make that clear. If the segments are proportional, then the angles are equal. All right. So here we go, another shape. We've got LJ to JN. I find LJ, okay, and then I find JN, and I say MK to KP. All right, that makes sense. Now, that's going to set up our given. That's going to set up our proportional statement. Now, right here, we look at LJ and JN. We don't know how big it is. We know how big LN is total, but we don't know how big the little piece is. So if we said that the whole thing's 16, and this part here is JN, then what's left over is the total minus JN, or 16 minus JN. That's how big this piece is. So when I plug this into my formula, I'm going to use JN and 16 minus JN. That's the total length, cutting back off JN. So we go 16, take away JN, and that leaves me with JL. All right, so now we're going to substitute that in there. We're going to say, instead of saying LJ, we're going to say that LJ is the same thing as 16 minus JN. We're going to reduce the fraction. 12/9 is unnecessary. We're going to do 4/3. And now we can set up our cross product. We can distribute in. Now I've got 3 JNs, or negative 3 JNs, and 4 JNs. I'm going to add the 3 JNs over to get 7 JN. And now I want to divide by 7 to get JN equals 48/7. Notice that cannot reduce. We cannot make this any smaller than it currently is. So we leave it alone. So JN, this distance, JN, is 48/7. And this segment JL is some other value. We could find it out, right? We could do 16 minus JN and find out what that is. But it's not asking us to do that. It's asking us to find the length of JN. So that's the first part.